Welcome back. We've introduced the idea of information extraction and one of its core tasks, named entity extraction. Now we'd like to turn to a second core task of information extraction, the task of extracting relations or relation extraction. Consider the following sentence from a company report. International Business Machines was incorporated in the state of New York on June 16th, and so on. We'd like to extract a relatively complex relation about company founding. We'd like to know that there was a founding event and that the company was IBM, that the location was in New York, that there was a date, that the company was originally named CTR, and so on. So all this kind of facts about this large structured relation. That's the general task of information extraction as we've defined it. But we're going to define a simpler task of relation extraction, which we're going to call the task of extracting relation triples. So instead of these complex events, we'll extract things like founding year IBM 1911. So a simple relation between a predicate and two arguments. IBM was founded in the year 1911, founding year IBM 1911, and the same with location, founding location IBM New York. So a series of individual triples, and that'll be our task, extracting these triples from text. So for example, imagine the following Wikipedia page about Stanford University. Taking a sentence like the Leland Stanford Junior University, commonly referred to as Stanford University, and so on. From these fragments of sentences, we'd like to extract relations like the following, that Stanford is located in California, and we get that from located in Stanford, California, or founded in 1891, there is founded the university in 1891, and the founder was Leland Stanford, and here we have Leland Stanford. So from this kind of text, our job is to extract individual relations between the entities in the text. Relation extraction is important for all sorts of applications. Anytime we need some kind of structured knowledge, and the knowledge originally is in the form of text, it's more easy for an application to get that knowledge from a structured database. So we'd like to extract these textual facts into structured form. And that could be new structured databases, or we could be adding words to current databases like the WordNet Thesaurus that we'll talk about later, or Freebase or DBpedia that we'll talk about later today. These kind of relations are quite useful, for example, in tasks like question answering. So imagine the following question that's modified from a question that was asked on the Jeopardy show. The granddaughter of which actor starred in the movie E.T.? And in order to answer this question, we'd like to know that the relations in the question include acted in E.T., so we don't want to know who acted in E.T., and we have to know that someone is an actor and that someone is somebody else's granddaughter. So these kind of relations will help both in understanding what's being asked in the question and then finding the answer in raw text. That's all great, but what relations should we be extracting? Well, one set of relations comes from the automated content extraction, or ACE task, where 17 relations grouped into 6 classes were defined. So for example, we had the class of person-social relations. So we had family, so that's going to be related to a parent or a brother relation between people. Or we had physical location, something is located in some place or located near some place. Or affiliation with some organization. I might be the founder of an organization or the owner or some member of an organization. Or I might be the creator of some artifact, the manufacturer or inventor of an artifact. Or I might be a corporate subsidiary, or I might be a geographical subpart of some other entity. So these are all the kinds of relations that are in ACE. And so, for example, we might have the physical located in relation, and that might hold between a person like he and some kind of geopolitical entity like the state of Tennessee. Or a part-whole subsidiary that might hold between two organizations. The first organization, the parent company of the second organization. Or we talked about family relations, so again, holding between two people, that a wife and a husband are related by the family relation. Or we might have the founder relation that holds between a person and an organization. So here we have a relation between Steve Jobs and Apple. So these are the kind of relations that we extracted using the ACE set of relations. Of course, there's different sets of relations for every possible task. So for biomedical information extraction, we might want to use the UMLS, the Unified Medical Language System, which defines entities and relations as well. So for example, we have entities like injury or physiological function, and they can be related by relations like disrupts or location of. So for example, we might have some pharmacological substance, some drug, and that might cause some pathological function, might cause some disease or cause some problem. Or we might have some other pharmacological substance, or we might have some other pharmacological substance that instead treats some pathological function. So we have lots of different entities, in this case 134 of them in this data set, and 54 relations that can hold between them. Now for each application, we might have a different set of relations that might be useful. So for example, the sentence Doppler echocardiography can be used to diagnose left anterior descending artery stenosis. We might extract from that sentence a relation of diagnosis between this technique and this stenosis. Now there are lots of existing databases of relations that have been extracted from public sources like Wikipedia, for example. So to take that same Stanford University Wikipedia page, you may notice over on the right here a little structured part of the Wikipedia page that's called the Wikipedia info box. If we look in more detail at what we have there, we have in fact a set of relations. So we have type, private, president, John Hennessy, location, Stanford, and so on. So each of these kinds of relation names and the values of the relations. And if we look at the source for this, we can see the actual info box. And here, for example, we can see that the city of the university is Stanford, the state is California, and the motto, Die Luft der Freiheit weht, and so on. And so we can extract these relations directly out of the info boxes. State, the relation state, the relation motto, holding between Stanford and California, or Stanford and the motto. These databases that draw from Wikipedia tend to represent the information in what are called Resource Description Framework triples, or RDF triples. And an RDF triple is just a subject, some sort of predicate, and an object. So the predicate is what we're calling a relation. So location would be a predicate in RDF. So we have Golden Gate Park, location, San Francisco. So a location relation between Golden Gate Park and San Francisco. And databases like DBpedia, which draw on the Wikipedia info boxes to create these large databases of triple, in fact has 1 billion of these triples, 385 million of which come from English Wikipedia. And in other databases like Freebase, we have a lot of these kind of relations. So a common relation is the nationality of a person mentioned in Wikipedia, or their profession, or classification of a biological entity, or which locations are inside which other locations, that Paris is in France, and so on. We can also extract ontological relations. We'll talk about this more when we talk about thesauruses like WordNet, but every kinds of relation databases includes what are called ISA or hypernym or subsumption relations. So we know that a giraffe is a kind of ruminant, which is a kind of ungulate, which is a kind of mammal, and so on. So these ISA or hypernym relations are very important, and we can think of those as the same kind of relation and extract them with similar kinds of methods. There's a specific type of this kind of relation where we have an instance, and a particular entity like San Francisco, which is an instance of a city. So we can have a relationship between classes. The class giraffe is a subtype of the class ruminant, or we can have an instance San Francisco, which is an instance of a class-like city. And again, these relations can be extracted from text, and we can use them to augment databases or create new databases of our own. How do we build these relation extractors? There's a number of methods. Like all information extraction, as we saw with named entity tagging, we can handwrite patterns. And we'll talk about handwritten patterns for extracting relations. We can do supervised machine learning. And then there's a number of popular methods for doing semi-supervised and unsupervised learning for extracting relations, and we'll talk about those as well. We've seen that relation extraction is an important component of information extraction, useful for question answering and for building large knowledge bases from text.